Too Tall Toby's practice model 25080 one-line cube is very interesting from the point of view of symmetry. The circular symmetry of its structure is clearly visible in the isometric projection, but it is not easy to immediately understand how to create such a structure as simply as possible. Let's imagine that the given figure is a part cut out of a full cube. It is easy to notice that the axis of symmetry passes through two opposite vertices of the cube and coincides with its diagonal. However, none of these vertices coincide with the elements of the one-line cube. This means that we must separately calculate either the position of the axis of symmetry relative to the figure or the position of the figure relative to the axis of symmetry. Let's consider the second option, since it is easier to solve it by tying the entire construction to the origin. At the same time, it is noticeable that the circular symmetry in this figure is not the only one. Mirror symmetry also exists, and in fact the body consists of 6 similar figures. Therefore, we can create only 1/6 of the figure and multiply it. Let's start from the beginning. I will show 3 options in Onshape, but you can also build a figure in other CAD systems using the same principle. Let's create a new plane parallel to the front plane at a distance of 80 millimeters from it, and on this new plane we will create a sketch of 1/6 of the figure according to the given dimensions. Let's select the necessary parts from the sketch and extrude them towards the inside of the imaginary cube. We have created 1/6 of the figure. Now we can mirror it and we have obtained 1/3. Let's hide the base planes and create the axis of rotation as a straight line in 3-dimensional space. Its starting point should coincide with the origin, but the endpoint should be the same distance from it in all 3 directions. The length of the axis does not matter, we choose it freely. We only need to remember that, in this construction, y will have a negative value. Using the circular pattern, we rotate 1/3 of the shape around the line we just created and obtain the desired shape. The same figure can also be obtained in another way, without using the axis of rotation. Let's turn to a little theory. The axis of symmetry we have created has only one point in common with each of the basic planes of the origin. However, by creating midplanes between any 2 of them, we obtain 3 planes and the axis of symmetry coincides with the line of their mutual intersection. As we can see, these new planes are located directly between the thirds that make up the figure, and the complete figure can also be obtained with mirror symmetry. Let's return to the construction at the moment when we have obtained 1/3 of the complete figure. First, let's create a midplane between the front and right planes, then between the front and top planes. Then, let's mirror the created figure against one, then against the other midplane. The result is exactly the same as in the first workflow. At the feature level, not only solids can be transformed, including creating patterns and mirror images, but also surfaces, sheet metal, and frame elements, as well as lines and curves located in three-dimensional space. These insights are the basis for the third construction of a one-line cube. This is not the most rational solution for this figure, but it is effective enough to demonstrate it here. It should be noted that in this construction it will not be possible to use the dimensions given in the drawing in a pure form, but the necessary ones will have to be obtained by calculation. The idea of the construction is to create a sweeping path of the full figure, along which to extrude a square of the cross-section of the figure elements with a side length of 10 millimeters. First, let's hide all the base planes, because we won't be using them in this workflow. Then, let's create a new plane parallel to the top plane and offset it by 5 millimeters. On this plane, let's draw a sketch to get the L-shaped centerline of the base elements of the figure. Using one of the lines of the sketch we just created and its outer endpoint, let's create a new plane on which let's create a sketch of the center line of the figure's vertical wall elements. Let's combine the lines of both sketches into one three-dimensional curve. Let's create an axis of rotation according to the principle described in the first example. Using a circular pattern, let's rotate the line created from the sketches around the axis of rotation and obtain a complete skeleton of the figure's elements centerline. On the last created plane, let's draw a sketch of the cross-section of the figure. Let's extrude the sketch along the entire skeleton curve with the sweep tool, sequentially selecting its sections and obtaining the desired figure.